Hi, welcome back to Moose in Chemistry. This is Colligiatve Properties Van Hoff factor lesson number 1. Hey, the Van Hoff factor is I, and it deals with ions and ionic compounds. If you have a polar covalent or a covalent compound, the Van Hoff factor is always going to be 1. We're also going to be using molality in this problem, which is moles of solute over mass of solvent in kilograms. All right, let's go ahead and get started here. So, given 2 moles of MgCl2 and 1,700 grams of water, what is the Van Hoff factor and what is the freezing point depression? Okay, we could do this problem quite easily. First thing that we want to do is convert 1,700 grams of water into, of course, kilograms because we need kilograms. Remember that it is mass of solvent in kilograms, right? So we write down 1,700 here. Move the decimal 1, 2, 3 places, and that gives me 1.700 kilograms. Okay, so now what we're going to do is we're going to go ahead and figure out the Van Hoff factor. Well, the Van Hoff factor is easy. You go MgCl2 is going to break down into Mg plus 2 ion, plus we have 2 of those Cl, so it's 2Cl negative 1. So the Van Hoff factor is going to be 1 plus 2 equals 3. So I is going to equal 3. Okay, now what we want to do now is figure out the molal. So we go M equals 2 moles on top divided by 1.7 on the bottom, and our molal is going to equal 1.18. 1.18. That's our molal. Now we are ready. So we found out the Van Hoff factor, and now we're ready to do the freezing point depression. Now remember, the freezing point depression is delta TF equals I KFM. And this time, I is going to be more than just 1 because it's an ionic compound. So the Van Hoff factor is 3. Freezing point depression, the KF, is negative 1.86 degrees C over M. And that's different for different solutions. So that's why we don't put it up here. All right, so now we're going to get our molal, 1.18 for our molal. So our M's cancel out, and after we do the math, the delta TF is going to be negative 6.55 degrees C, and that's our freezing point depression. Well, listen, you guys, you be snarly, and we'll see you back here at Moose in Chemistry.